All right, section 1.5, function notation. Let's just jump right into it here. So what we need to be able to do, we need to be able to write functions using function notation. And then we need to be able to evaluate. That just means find a value, find a number, answer. And then we need to be able to graph these functions. So it says, many times a set of ordered pairs can be described using an equation. As long as every input is mapped to exactly one output, then it can be written in function notation. So that was kind of like the last lesson. We looked at relations and made sure that the x's were being mapped to exactly one y. So think about it like a machine. So you kind of have this spot on top here where numbers are dropping in. And then you kind of have this little spot here on the bottom where numbers are dropping out. And so I want you to think of this as the input, and out here is going to be the output, and then there's some sort of rule inside there. So in this case, the f is just the name of the function. So this is called the f function. This is the input, so we're putting x's into there. All right, so my x's are going in. And then f of x, this whole entire thing, that's the output. Now, it was always easier for me to just really think of f of x is just y. All right? It's just a fancy way for writing y and saying what the answer is after you put some different x's in. So if you were going to make a table, you know, and you made a little xy table back in the day, well, it's really just an f of x table. It's kind of how you can think of it. All right, so let's pretend that we drop, I don't know, let's put a 0 in this box. So a 0 drops in, and the rule says that we need to do 5 times whatever x value, and then add 3 to it. So if you plug 0 in there, 5 times 0 is 0 plus 3, you're going to get a 3 pop out. So we know that 0, 3 is a solution. Now, how we write that is you'd say f of 0 equals 3, because when you put 0 in, 3 popped out. And then you try another number, and maybe you plug in, you put a 1 in there, and you drop that 1 in. Well, 5 times 1 is 5, plus 3 will give you an 8 will pop out. So we know that 1 comma 8 is on there. And I could say that f of 1 is 8. Input 1, output is 8. So that's kind of how function notation works. So if I said, hey, what is f of negative 12? Question mark. You're like, oh, I just plug negative 12 in. I just do 5 times the negative 12 and add 3 to it, which would be negative 60 plus 3, or negative 57. So f of negative 12 would equal negative 57. So that's kind of how function notation works. So let's move down and check out an example. It says for each function, evaluate, meaning find the answer, there's 3 of them here. So you have 3 inputs. We basically, like another way of saying this would be to say, hey, we want you to figure out when x equals 0, x equals 1/2, and x equals negative 2. Well, you could do it by hand. Like if you wanted to, you could come over here and you could say, well, f of 0 is 7 minus 2 times 0, which I think is just 7. All right? So there's that answer. F of 1/2, well, when I plug 1/2 in, 7 minus 2 times 1/2. Well, 2 times 1/2 is 1, so 7 take away 1 would be 6. And then we need to do negative 2, f of negative 2. Well, that's 7 take away 2. And basically, you're just replacing that x with all the different numbers they're asking for. And that would be 7 minus 2 times a negative 2, or 7 minus a negative 4, 7 plus 4. Looks like it's going to be 11. All right? So there are our 3 values. Now, sometimes, so here they give me an equation. Number 2, they actually just give me a graph. So what it's basically asking on this one is it's kind of saying, hey, you know, f of 0, well, that means when x equals 0, what do we have? Well, if I go to x equals 0, it looks like it's 4, all right? Because when x is 0, y is 4. That point is on the graph. Now, if they say f of 1/2, well, when x is 1/2, what is y? And I kind of got a guesstimate on this one. If x is 1/2, then y looks like it's somewhere around right in there. So maybe 3.5. So I think when x is 1/2, y would be about 3.5. And then finally, when f is -2, well, -2 is right here. Looks like when f is -2, y is +2. So these ones show up a lot on the SAT, where you have to evaluate a function given the graph. And sometimes kids kind of, they look at these backwards. So just make sure you kind of do it the way that we just did it right here. All right, next little group. Graph each function for number 3 and number 4. So let's see what we got going here. We have the maximum recommended heart rate for women. So they only give me 5 relationships. Like, I don't really know what the maximum heart rate is for a 32-year-old or a 27-year-old. You know, I might be able to kind of like guesstimate it's between those two numbers. But whenever you see this and it's just, they only give us a relation of 5 different things. This is called, it's going to be a discrete graph. Discrete meaning that it's not continuous. And that'll make more sense when I put it on the graph over here. Continuous. I think I misspelled that. All right, well, let's go to our graph. It looks like our age and time usually go on the bottom. So we're just going to kind of put that over. And we're going from 0 to 40. So maybe I'll go 5, 10, 15, 20, 25, 30, 35, 40. Now, I notice all of these numbers are between like 180 and 200. So it may not, don't write this down me right now, but it may not make a lot of sense to, you know, come all the way up here to the top and put a 200 up here. You know, maybe like here, and then come down and do 100 here. You could do that. You know, you could do that, and you'd have like 25 and 50 and 75 and so on and so forth. The problem with this, though, is you're going to have all of your numbers smashed in right here, because all of these numbers are between 200 and 180. So your graph is going to have a lot of white space. So sometimes what they'll do, and I just want you to recognize this because on the SAT they do this sometimes, they'll show that there's a break in the graph, and it'll kind of come up, and then it'll have this kind of little squiggle. So it'll go up and then like that. And then maybe they'll start it right here, and they'll say, you know, hey, 170, 175, 180, 185, 190, 195. What do we got to go to? 210, 200, 205, 210. So I just want to give you an option. You're allowed to not start at 0, but you do have to put this break in here. And unfortunately, sometimes on the SAT, that break screws you up, and it messes things up. So just, I want you to be aware when you look at a graph and you see that things could be distorted a little bit. All right, the graphing part should be pretty easy. We'll put these dots on here. 0 at 209. At 10, you're at 202. And 20, you're at 195. 30, you're at 188. And 40, you're at 181. So, looks pretty linear actually, because it looks like it's just decreasing by 7 every single time. So it looks like there's a linear relationship here. You're not allowed to connect them. So don't connect, because just based on the data that we've been given, these are the only relationships that we know. We don't know the in-between numbers, so that's why this is called a discrete relation or a discrete graph. All right. Now contrast that with once you have an equation, all right, once you have an equation, you could connect the dots if you wanted to. So to graph the function, let's do that first. So here's our function. Remember, it's really just y equals x squared minus 2. And you have a couple options. You could start plugging it out by hand. You could kind of make a table, and you could kind of start getting numbers, x's and f of x's, and go down that route. Or we could use our graphing calculator. Let's do that. So I'm going to use the graphing calculator and pull him up and slide it over. I don't know, maybe right here. So I can still see my graph and still see on the left. So let me quit out of this. So I'm going to go to my y equals in the upper left, and I'm going to punch in x squared take away 2. So my variable is next to the green alpha key, x, and then squared minus 2, and I hit enter to lock it in. Now I could go to graph and try to kind of copy the graph, which that wouldn't be too bad. I could go over here, and it's okay, but it's just kind of a sketch. It's not really that great. So I think it would be better to go to second graph where you can see the table of values. And now we could kind of get some numbers. So I'm going to go up so I get a few negatives in here. So trying to put what's actually on the graph, I think I can use that little XY table. And I could say, well, negative 3, 7 is on the graph, which is going to be up here. Negative 2, 2. Negative 1, negative 1. 0, negative 2. 1, negative 1. 2, 2. And 3, 7. And since this is an equation, all right, since it's an equation and not a map, this is continuous, and I am allowed to connect these dots, just kind of roughly, and back on up. So there you go. So we've now graphed the function. I think there was something here behind my calculator that they wanted us to see. So we need to define f of negative 2 and f of 1. So at negative 2, so that's basically saying f of negative 2 is really saying, what is y when x equals negative 2? That's what it's asking. So when x is negative 2, it looks like y is positive 2. And then what about f? What is the f function when you input a 1? Well, when I put a 1 in, I get negative 1. So there are my two answers for that one. All right, moving right down. In a certain country, the fines for speeding in a school zone are $160 plus $4 for every mile an hour over the speed limit. Write a function to represent the speeding fines. So we need to write our own function. So I need to write my own f of x to represent that situation. Well, it may be helpful to kind of make a little bit of a table. Let's kind of make a little y table, xy. And let's say that you are doing 1 mile an hour over. All right? Well, if that was the case, you got to pay $160 plus $4 times your 1 mile over. So it'd be $164. Well, what if you went 2 miles over? Well, that would be you'd pay the fine plus 4 times 2 miles over, so it'd be $168. And let's just go jump down a little bit because it says, hey, what is f of 8? I could jump down a little bit to 8 and say, well, I'm going to pay the $160 fine plus $4 times 8 miles over. That's $32 kind of penalty. So now my fine's $192. So in general, notice what's changing. Everything is staying the same except for this value here. It's varying, it's changing. So I think my equation could be 160 plus the $4 times every mile an hour over. So there would be a nice function that represents that table. And f of 8, we just determined, is 192. So I just evaluated it. I found a value for it. Now, explain what it represents. It basically says that if you go 8 miles per hour over, then your fine is $192. So that's what this represents in the real world problem. All right, moving down, number 6, it says a set of input values is sometimes referred to as the replacement set. So this is just kind of other applications. They may give you a replacement set, and these are basically just x values to plug in, but the notation looks kind of weird for the independent variable. So we're going to evaluate the function below given the replacement set. Try to use the table feature on your graphing calculator. I don't want you to have to plug in, all of these by hand if you want to use the table feature. Now, the only problem with that I see is this one has a 0.5 and this one has a 0.25 or a quarter. So you'd have to kind of have your table go by 0.25s. So here might be something you want to do. Like I look at all those numbers and I see the smallest number is -3.5. So this is where I may want to have my table start. And I noticed that I need increments of 0.25. So I need my change of the table to be 0.25. And that way it'll go up by increments of 0.25. All right, let's pick up where we left off. Boom. So looking at the replacement set, looking at the x's we need to plug in, I said that the smallest is -3.5, so I'm going to start my table there. And we need to have increments of 0.25. So let me show you how to do that on the graphing calculator. One other thing is I need to know the equation I'm going to punch in. So this is f of x equals 3x minus 6. Remember, I'm just going to treat f of x like a y. All right, so let's knock it out on the calculator. Now you could, if you want to plug all these in separately, you could do that a bunch of times, but I'm going to show you how to speed it up. So here we go. Calculator up, move it over, get my numbers back in a second. All right, so we have 3x minus 6. So I need to go back to my y equals, clear that out. 3x subtract 6, enter, lock it in. Now I'm going to go to my, if I go to my table, I'll show you what it looks like. If I go to my table, I'm not going to see all those little pieces. Like I'm not going to see 3.5 and a quarter. I'm only seeing integers. It's going up by ones. So what I want to do is I'm going to use table set. So I'm going to go second window. And I'm about to adjust this table. So we wanted to start the table at the lowest number, -3.5. And my change, my delta table, that little triangle table, I want to make that at 0.25. So now I'm going to see every 0.25 increment. Bam. And let's go back to the second table and we'll look at it. And now you'll see that it's changed. So I have some values here. I don't think I can have the calculator up and the, well, maybe I can. Let's try it. Oh, nice. So let's go ahead and put these values in. So f at -3.5 equals, right there, -16.5. F evaluated with an input of -1. I'm going to have to scroll down on my chart because it stops at -2. So go down, 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 down. And there's -1. I can get 0.25 in the mix. It's about as good as I'm going to get on this screen. So -1 is going to be right here at -9. F of a quarter, aka 0.25, is going to be right here, which is -5.25. And then lastly, we got to go all the way to 2 and 11. So I could do a lot of scrolling. I could go back and change my table set. I think I'm just going to do a lot of scrolling. So let's knock out 2 and 11. There's There's 2. So 2 is 0. I'm just going to remember that. And then we need 11. And 11 is 27. So I'm going to update this. So f of 0, or wait, f of 2 was 0. And then the function evaluated at 11 is 27. Now, it seemed like it took a while because I'm like talking through the whole thing, but if you're actually doing your homework and you're good at the table, it'll be much faster to use this table than to plug all those numbers in separately. All right, hopefully this helps with the homework. If not, ask me questions tomorrow. See you.